In my bathroom, there is a soap holder that has a form of a right triangle. The sides of this soap holder are 20 by 15, and by doing the Pythagorean theorem, we got that the hypotenuse was measured at a total of 25. In order to find the other two angles that are missing, we will need to do the inverse function of sine. This means raising sine to the power of -1 and putting the opposite side of it over the hypotenuse. Then we will get our result. Angle for A we got was 53.1, and by subtracting that to 180 plus 90, we also got as a result an angle C 56.9. In order to get the sine of A, we need to get the opposite side of the triangle over the hypotenuse, so it's 20 over 25. Then the cosine of A would be the adjacent over the hypotenuse, 15 over 20. Then the tangent would be the opposite of the triangle over the adjacent, so that would be 15. Now, to get the other three trigonometric ratios, we're just basically gonna flip the values around. And for example, in sine and cosecant, it will be 5/4. In secant and cosine, it will be 5/3. And in cotangent instead of tangent, it will be 3/4. The sine for C would be 15 over 25. The cosine 20 over 25, and the tangent of C would be 15 over 20. So the cosecant of C would be 5/3. The secant of C would be 5/4. And the cotangent of C would be 4/3. Now, in this part of the project, we will see how we can calculate the height of a street light with just our angle of elevation and the measurement of its shadow. But first, we wanted to try an experiment with one of our team members, in this case myself. We needed to measure my shadow, which was approximately 125 centimeters, my height, which is 189 centimeters, and then with that we will want to calculate the angles remaining. So with the Pythagorean theorem, we can calculate how much the hypotenuse will measure, and with that and the inverse function of sine, we can get now our angle of elevation of the sun. So it would be sine to the negative power of 1, parenthesis 189 over the hypotenuse. So at noon, when we measured the shadow of the street light, we got that it measured 3.17 meters, or 317 centimeters. With this, and with the angle of elevation, we'll be able to calculate how much the height of this object is. So in order to calculate the angle of elevation, we would need to get our hypotenuse first, which after doing the Pythagorean theorem, we got it was 575.2 centimeters, and then by using the inverse function of sine, we can get that the angle measures. Thank you for being part of our project and listening and watching how we can calculate different things in our houses and right triangles with basic and more complex trigonometric ratios.
Created using Powtoon.